Do you sometimes wonder when steel production will be carbon neutral? And what does it take to produce quote-unquote green steel? I'm Kata. Grab a cup of coffee and let's talk about it. Fossil-free steel production is very near and dear to my heart because my engineering PhD was about the thermomechanical treatment and composition of a specific high-strength sheet steel for the automotive industry. In this video, we'll look at the production, the cost, the emissions, the investments, as well as the players in the market of green steel. So please subscribe below and let's get started. On average, for every ton of steel produced, almost 2 tons of carbon dioxide are emitted. Although 90% of steel is recycled, this accounts for 7% of global emissions. So cleaning up steel production is clearly key to a low-carbon future. Fortunately, new paths are emerging. HYBRIT, the Swedish hydrogen breakthrough iron-making technology, has delivered the first batch of low-carbon steel. It is the first steel made without any coal and brings down the carbon footprint from 1,600 to 25 kilograms per ton of steel. This is amazing. So is this it? And can we move on to the next climate challenge?
We are a step closer now that multiple technologies are getting tested at scale by multiple companies out there. Most of the major steel manufacturers are investing and have announced for first-of-a-kind plants to test new technologies that produce zero-carbon steel. The problem now is really to deploy those technologies at scale. The announcements until now have been of a handful of projects, and we have more than 500 plants around the world that need to shift to those new technologies. So deployment is going to take time, and it's going to be a major investment challenge.
Significant changes in highly mature industrial processes require lots of time and resources for commercialization. This batch is a major breakthrough. However, it's one step of several required to produce fossil-free steel at scale. So what is green steel exactly? There are two ways to produce fossil-free steel. One way is by replacing the reducing agent carbon or coal in the form of coke by hydrogen. And the other way is to use the so-called molten oxide electrolysis. Most major steel manufacturers work on the hydrogen-based process. Blast furnaces are still used to process iron ore into molten iron, in principle the same way as they have been for the past 1,000 years. Coal and coke are used to reduce the iron, which results in CO2 emissions. For fossil-free steel production, HYBRIT employs direct reduction. Fossil-free produced iron ore pellets are used and hydrogen serves as the reducing agent. This steel-making process emits ordinary water instead of carbon dioxide. The fossil-free steel is estimated to be available on commercial markets by 2026. How much does fossil-free steel cost? Steel is a commodity with little price elasticity. Changes in the process can result in reduced quality, adding a premium to the steel where needed. Since steel production in principle has been the same process for thousands of years, there has been plenty of time for iteration-based optimization and cost efficiency. It will take time and resources to reach the same level of maturity with fossil-free steels. Ultimately, the competitiveness of a steel production process depends on the per-unit price of resources such as electricity and raw materials. According to the Rocky Mountain Institute, the hydrogen-based process is already competitive with the traditional steelmaking process at about $40 per megawatt-hour electricity price. That corresponds to 4 cents per kilowatt hour. Molten oxide electrolysis is expected to be competitive at electricity prices ranging from about $15 to $30 per megawatt hour. Wholesale electricity prices can range anywhere between about $20 to $100 per megawatt hour, with occasional peak electricity prices of up to $9,000 per megawatt hour. So what's happening in the market? As mentioned, HYBRIT, a cooperation between SSAB, Vattenfall and LKAB, produced 100 metric tons of hydrogen-reduced sponge iron made in Luleå, Sweden.
This is not our sustainability strategy, it's our business strategy, and it is sustainable.
The The HYBRID partnership noted in a statement that the test delivery is an important step towards a fully fossil-free iron and steel production value chain and a milestone in the HYBRID partnership between SSAB, Vattenfall and LKAB. HYBRID says that the goal is to deliver fossil-free steel to the market and demonstrate the technology on an industrial scale as early as 2026.
We have huge challenges, and those processes do take time, and that's time that we don't have for us to meet the ambitious time plan of having fossil-free steel by 2026 and becoming first in the world with this. So we have a time plan challenge, and it requires that everyone cooperates for this to happen.
To get a more detailed understanding of the CO2 emissions reduction, feel free to have a look at the MDPI article by HYBRID linked in the description below. All major steel manufacturers are working towards lower emissions. Of course, there is a need for public relations in this emissions-heavy industry. However, I think there are many qualified individuals in the industry that are working really hard to carve a path towards fossil-free steel production. voestalpine, for instance, built the largest pilot facility for hydrogen production in the steel industry in Linz, Austria. The world's largest pilot plant for carbon-free production of hydrogen is based in Linz. Green hydrogen is being tested in various process steps of steel production. The long-term goal is to replace fossil fuels like coke or coal. In addition, researchers are examining the potential of hydrogen for energy storage and for possibly compensating the fluctuations in the electricity grid. The core of the plant is a highly dynamic proton exchange membrane electrolyzer with a capacity of 6 megawatts. This plant produces 1,200 cubic meters per hour. Electricity is used in this process to break down water into hydrogen and oxygen. The EU-funded H2 Future project has a volume of 18 million euros, and the project partners are Verbund, Siemens, Austrian Power Grid, K1 Met and TNO. The electrolyzer has a capacity of 6 megawatt and is regarded as the most effective and advanced facility of its type. It will be used to test whether the technology deployed is suitable to produce green hydrogen on an industrial scale. voestalpine's phased plan aims to achieve carbon-neutral steel production by 2050. Part of this plan is to enable CO2 savings of 30% by 2030. This will gradually replace the conventional blast furnace route with electric arc technology powered by renewable energy. The key factors to maintain consistently high production quality are an intelligent materials mix and raw materials optimization. ArcelorMittal announced that its Sestao plant in Spain will become the first full-scale, zero-carbon emissions steel production plant. By 2025, the Sestao plant is expected to produce 1.6 million tons of zero-carbon emissions steel. Baowu partnered with one of its biggest iron ore suppliers, Rio Tinto, investigating ways to reduce carbon emissions in steelmaking. Another partnership with Honeywell aims to produce hydrogen energy to reduce emissions as well. However, the announcement did not say where the hydrogen will come from. I'd like to point out that there are excellent answers to FAQs on the SSAB website linked in the description below. That's it for now on fossil-free steel. Let me know what your thoughts are and see you in the next video. Bye!